likely to happen.
Right.
But it's close enough that it really has attracted a lot of attention. But here's the important thing. Think about the size of it. We just talked about the Earth and the Moon and the relationship to them. Let me come in here and show you a little bit more about this thing. You mentioned 2012 DA14, a very lyrical, spacey name. It's about 50 yards long. Close, this pushing 18,000 miles an hour. That's really cooking through space. Not uncommon for space, but for all those on Earth, it seems incredibly fast. And if it were to hit Earth, if it could hit Earth, it would basically explode with the force of more than 2 million tons of dynamite, which sounds really, really huge. And it would, in fact, wipe out an area of several hundred miles in all directions. But it would not be a cataclysmic Earth-ending event, even if we were hit by something this big. But it would be something we would certainly take note of, Brooke.
Well, I'm glad that 2 million tons of dynamite is not hitting Earth at all. Apparently that happens one in every 1,200 years, so we're going to skip that for now. But Tom Foreman, I appreciate the 3D illustration just to sort of put this in perspective size-wise and all these different numbers. And as this asteroid here is hurtling towards us here on Earth, only people in Eastern Europe, Australia, and Asia won't need some sort of major equipment, some sort of telescope, telephoto lens to see this historic space moment. And it's a moment, no doubt, that the experts at Hayden Planetarium in New York are savoring, and that is where CNN's Jason Carroll is live. It's the planetarium, part of New York's Museum of Natural History. Tell me how excited they are.
Oh, I mean, this is one of those rare events. I do want to bring something up, though, when we talk about this type of event happening. It actually did happen before, back in 1908. Of course, the outcome was much different. In that case, the asteroid and/or comet actually struck the planet. It was in, of all places, Siberia. Happened in 1908, and it apparently exploded above the surface of the planet. But still, even though it did that, it wiped out 825 square miles of forest. So think about that. So in terms of danger, I mean, I think that's why scientists are watching this event so very closely. I'm going to bring in one scientist right now, Dr. Denton Abel. He's curator of meteorites, like the meteorite you see behind me here. Obviously, you've been looking at this situation very closely, at least for the past year.
Well, really only for the past week, because we actually... was discovered as a thing that was near the Earth in February of 2012. Right. But it was only in the last few weeks that it really became apparent that it was where it was actually going to go, because we got much better data on its trajectory.
And that brings us to a next point. And Brooke is a space geek like I am, so we talk about this and study things like this, but that's pretty scary, because when you think about trying to deflect something like this, we wouldn't have the technology in place right now to deflect an asteroid if it were to hit the planet and we found out a week out, 2 weeks out, even a year out.
Yeah, that's correct. We have some capabilities, but we don't have big time capabilities to deflect something, even something small like this. However, we do know where a lot of things are that are really dangerous. This one, as you said, Tunguska is the touchstone for an airburst, which this would be if it hit the Earth's atmosphere. It would explode above the ground somewhere. And
like what was seen in 1908.
Yes.
And we don't have the capability, but I think it begs the question, why don't we? I mean, I'm wondering if scientists, NASA, the government, wherever the government may be, whether it's here in the United States or in Europe or in China, will look at this particular event and start to change things.
Well, would you like some other government to decide to do something about this on their own?
I just want someone to do something about it if it's going to happen.
Well, this one isn't going to hit us,
right.
And it's not even going to hit our satellites, which is
right.
great also. But you're right. We need to think about this as a globe, as a civilization, as humanity itself, because I think it's beyond the capabilities of any single nation at this time to mount planetary protection. It's a lot of work.
Well, it's something we definitely need to be thinking about. We were also talking about, how this particular asteroid, what it's made up of. This meteorite that we see behind us is dense. It's made up of ore, but the thinking is this one, as you'll be able to watch it tumbling past the planet, might be a little bit more porous.
Oh, well, most of the asteroids that we've flown by with our spacecraft are porous rubble piles of stony material. Actually, only about 4% of rocks that come to Earth as meteorites are irons, which is a small percentage. Most of them are stony meteorites, and they come presumably from these porous asteroidal bodies. But of course, something that's really porous and poorly held together won't make it through the Earth's atmosphere very well. So it's a mixture. The ones we have in our collections tend to be the chunks of rock that are tougher.
So now we're just a few minutes away as we look at some of the feeds coming into us now and some of the animation that we look at as well. Looking down now at 2:36:35 as we get a countdown. That's the animation that we've been using. Look accurate to you?
It's, well, we don't know the shape of the asteroid yet, but we may get it from radar as it goes by. We will train Goldstone radar in California, and the UK will train their radar arrays on this object, and they can model the shape by the way different parts reflect radar and Doppler shifts and so forth. And we've done this actually using bigger radar, the Arecibo antenna, actually on asteroids as far away as the asteroid belt itself.
And you know, there's also this theory about, okay, let's just say, what could you do to try to deflect one of these asteroids from hitting the planet? I mean, this is right, but I guess we're going to get into that a little bit now as we come down.
Well, I like deflection if we know it far enough in advance. And actually, what we have done as a civilization is enabled people, and people across the globe are actually finding these things.
Okay, very
Jason,
good.
let me
We're going
jump
to throw it
in.
back to you, Brooke, as we're now just a minute away.
Yeah, we are encroaching upon, thanks to you and Denton Abel, we'll come back to you, but we're coming upon this point, 224, 225, that's the point in which this asteroid will be the closest to Earth. Let's just eavesdrop, let's listen in on NASA TV.
From this asteroid for a long time.
And how will you use the information that Lance was talking about, the information that the radar can give us?
Lance's information is very helpful in computing the orbit. We will have essentially nailed the orbit of this to, it'll be one of the best in our catalog. It's that accurate.
All right. We are 50 seconds away, 49. The clock is counting down, and at that point, in just a few seconds, that is the closest point that DA14 will be to our planet.
To our planet in centuries, probably, as far as we know. So it's a remarkable moment as it passes by, and then it will be headed out.
And I'm watching the counter on the left, the distance to Earth.
Yes, it's going to go through about 17,200 some miles. That's as close as it will